Okay, so we're moving into the second half of the WJEC Intermediate Tier Maths from November 2019, and we're into the CB questions. Question 12, transformations. Describe fully the single transformation that transforms triangle A onto triangle B. So that is my original, and it becomes that. So it's been flipped, so it's a reflection. So the first key word is reflection. That gets you your first mark. But in order to describe fully a reflection, you need to say where the mirror line is. Where's the line of symmetry? Where is the line that it's reflected through? And hopefully you can see straight away that it's that line there. So this is the line where the mirror is going to sit. So we say reflection, first mark, along the line. And then we need to describe that line. And this is where so many intermediate tier students make the mistake that I'm about to describe. That line goes through the point where the x coordinate is -2. It doesn't matter where you are on that line, that point has got the coordinate -2, 1. That one's -2, 2. That one's -2, -3. Every single point on that line, x equals -2. So the line is x equals -2. But because that line is running parallel to the y-axis, students think they're wrong by writing x equals -2 because it seems more logical to them that is parallel to y, so it's y equals -2. It's all to do with the coordinate. If it was reflected horizontally, then the y coordinate would be fixed. So it would be y equals, even though it's running parallel to the x-axis. So it frustrates me so much that no matter how many times I say to that and say to students, watch out for that, you will get it wrong, I'm still marking y equals -2 time and time and time again. So there's one mark, finish my rant, there's one mark for spotting, it's a reflection, and the second mark is for saying where that mirror line is going. Translate. Triangle A using the column vector 5 - 6. So with a translation, that shape is just going to move along the axis, along the grid. It isn't going to change, it's not going to rotate, it's not going to flip over, it's going to be in exactly the same orientation but on a different position. And what you do is you pick one corner of the shape, and that's what we're going to translate. And the way that this works is the top number tells you how its horizontal movement is going to take place, and this is across 5. And because it's positive, it's moving in the positive x direction. This is saying down 6. Down because it's negative. If it was positive, it would be moving up. So I'm moving this across 5 squares. 1, 2, 3, 4, 5. And then down 6. 1, 2, 3, 4, 5, 6. So that corner of the shape is going to end up there, and then the shape is going to be in exactly the same orientation. So the base of it is 4 squares, so use a ruler and a pencil when you do this. Got a height of 2, so that is where it ends up. Write on the column vector that will reverse the translation. So to reverse it, I want to move it back to where it started from. So rather than going positively 5, I'm going to go negatively 5. And then instead of going down 6, I want to go up 6. So that will be, so in order to reverse the transformation, you just reverse the signs on the numbers. So for this, there's one mark if you've correctly moved it 5 places, one mark if you've correctly moved it 6, and one mark if you've correctly reversed the signs. Question 13. The exterior angle of a regular polygon is 36 degrees. How many sides does the polygon have? So you need to know a little bit about angles of polygons. The exterior angle in a polygon, if I just draw, what have I got here, a hexagon. Okay, the exterior angle on a hexagon are the angles along the outside of the shape as you travel around the shape. So those are the exterior angles. And in that instance, there are 6 of them because it's a 6-sided shape. And if you start there and you're facing in that direction, and each time you go through a turn, once you come back to the start, you're facing in the same direction again. So you've turned through 360 degrees. So in order to work out how many turns you've made, which then gives you how many sides, you're going to do 360 divided by each little angle, which is 36. So when you do 360 divided by 36, you get 10 sides. Calculate the sum of all the interior angles of this regular polygon. Well, the interior angle, that's the exterior one, that's the interior. So the exterior and the interior together make up a straight line, which is 180 degrees. So one interior angle will be 180 less 36 degrees. Okay, so however you want to do your subtraction, can't take 6 from 0, so I need to write it as 170 10 instead of 180. That means then 6 from 10, 3 from 7, and 0 from 1 is 144 degrees. So each of the interior angles will be 144 degrees, and because this is a 10-sided shape, there'll be 10 interior angles. So that will then be 1440. So long as you know what part of the polygon an interior and exterior angle are, that's quite straightforward. Method mark, 360 divided by 36. Answer mark, 10. Method mark, finding one interior angle. Answer mark, multiplying it by 10. Question 14. Nth term rules. Write down the first 3 terms of the sequence whose nth term is given by n squared minus 6. So I'm not going to teach you nth term rules here. I'm going to show you how to figure out the answer, but if you need to practice those, you need to go and find some work on nth term rules. They should, for an intermediate tier student, be easy marks. Okay, so write down the first 3 terms of the sequence whose nth term is given by this. So the first term means rather than having n in that rule, we're going to have the number 1. So the first term is going to be 1 squared, take away 6. 1 squared is 1 times 1, which is 1, take away 6. 1 take away 6, negative 5. So the first term, negative 5. Second term now, same rule, but the n is now 2. It's position 2 in the sequence. So it would be 2 squared, take away 6. 2 squared is 4, take away 6. 4 take away 6, negative 2. Third term would be 3 squared, take away 6. 3 squared is 9, take away 6. 9 take away 6 is 3. Write down an expression for the nth term of the following sequence. So this time they want you to come up with the rule. The way you come up with the rule is you look at the differences. This pattern is going up in 6s. So it's going up in 6s, That's telling you it's a 6n rule. It's basically the 6 times table, but it's been moved. If it was going 6, 12, 18, it would just be 6n. But it's been pulled back one space because it doesn't go 6, 12, it goes 5, 11. So to work out the shift, once you've worked out what the gap is, you then see what the difference is. So in order to move from the 6 times table, I've got to go back 1. So take 1. Okay, so for that one, let me just find my mark scheme. There's 1 mark if you got any 2 of them correct. 2 marks, of course, if you got all 3. There's 1 mark if I see 6n, and there's 1 mark if I see the -1 to shift it. Question 15. Right, for me this is the most horrible question on the paper. Don't like this one at all. Circle the correct answer for each of the following. So 81 is either 3 cubed, 9 cubed, 9 to the power of 4, and so on. So the first thing to figure out here is what cubing means. So cubing means timesing it by itself. So there's lots of space down here to play around with. So 3 cubed is 3 times 3 times 3. 3 3s are 9, 9 3s are 27. It's not that one. Now I know that 9 squared, 9 9s are 81, so it's not that one, and it's certainly not going to be bigger than that. I know 10 10s are 100, so it's not going to be that one, which means I'm left with 3 to the power of 4. 3 to the power of 4 is that times another 3, so we can just check it if we want. 7 3s are 21, 2 3s are 6, and 2 is 81. Then we come to part B, which is where I start not liking things. 2.1 to the power of 5. Well, 2 to the power of 5 would be 2 times itself 5 times. 2 times 2 times 2 times 2 times 2. 2 times 2 is 4. 4 2s are 8. 8 2s are 16. And 16 2s are 32. So 2 to the power of 5 is 32. So it could be that one. It's definitely not that one. It could be that one, it could be that one, it could be that one, because they're all bigger than 32. That one isn't, sorry, that's smaller than 32. So it could be 32.5, it could be 40 point that one, or it could be 32.1. So the next thing to figure is that because it ends in a 1, because I got 0.1 times 0.1 times 0.1 times 0.1, 1, 2, 3, 4 times 0.1, when you multiply 1 by itself, it doesn't matter how many times you complete that, you end up with a number that ends in a 1, because 1 times 1 times 1 times 1 ends in a 1. So my number is going to end in a 1, so I can knock that one off. So that leaves me a choice of 2, which is that one and that one. Now to decide which one of those it is, the fact that I've got a 1 decimal point number that I'm ending up multiplying 5 times means my answer is going to have 5 digits after the decimal place. So that one doesn't, that one does. So that is my answer. It's the only one it can possibly be because it's bigger than 32, it ends in a 1, and it's got 5 digits after the decimal place. And then part C, really tricky on the intermediate tier if you haven't done rules of indices. This is certainly an overlap with the higher tier. The power to a half is the same. There's another way of writing the square root. So it's another way of writing the square root of 12.96. Now if we think of square numbers, we know that 9 is 3 squared. So 3 is the square root of 9. 16 is 4. So the square root of 16 is 4. So my answer is going to be between 3 and 4. So I can knock out that. That's between 3 and 4. I can knock out that. That's between 3 and 4. And I can knock out that. So my answer is either going to be 3.6 or 3.3. If it's 3.6 squared, it's going to end up with a digit which is going to end in 6, because 6 is a 36. That one is going to end in the digit 9, because 3 3s are 9. So because what I'm looking for ends in a 6, that's going to have the smallest part of the number is going to end in a 6 as well. That one will end in a 9. It's not that one, it's that one. So that's really horrible as far as intermediate tier is concerned. 1 mark for each. Question 16. Constructions. Using only a ruler and a pair of compasses, so that's all we can use, construct a triangle PQR so that it satisfies both of the following conditions. Angle PQR is 60 degrees and PQ is 7 centimeters. So PQ has got a length of 7 centimeters, and the angle P, which isn't on the diagram, so it's going to be up here somewhere, P to Q to R is 60 degrees. So that means if we do a little sketch up here just to help us with what we're looking for, that's Q, that's R, P is up there somewhere, PQR is 60 degrees and PQ is 7 centimeters. So by doing that little sketch, it helps me know what I'm aiming for. So to construct a 60-degree angle, it's one of the basic constructions you're expected to know. You put the point of the compass where you want to form your angle from, so in our case Q, and we want to draw part of a circle. We then move the compass point to where that part of the circle crosses our QR line. And we bring it back through the first arc. When we join through that line, that is going to produce a 60-degree angle. And because we know we want it to be 7 centimeters, if I put the 0 on Q, go through that arc up to 7 centimeters, that's where P is going to be, and then I can just join the other side to R. Oops, bit of a wobble there. So P is there, that is 60 degrees, and we've got one of these in our pencil cases, so we can just check, put the center on Q, line the 0 up with the line and measure up, and you can see there that is 60 degrees, and we know that it measures 7 centimeters. They are looking for these construction arcs. If the examiner doesn't see those intersecting curves, you're not going to get the marks. They will assume you've measured, which they've specifically told you not to. So 2 marks for that. The method mark for the arcs for the construction, and the second mark for the 7 centimeter line and completing the triangle. Question B. Using only a ruler and a pair of compasses, so we can't put it away yet, construct a line from a point A that is perpendicular to the line LM. So perpendicular means that what we're looking for, again, if we do ourselves a little sketch up here, there's A. Parallel would be running through it to make a set of train tracks. Perpendicular means that we're running through it at right angles. There's a couple of different ways of doing this. Probably the easiest is to put your compass on one end, open it out so that the compass pencil goes through A, and then draw part of your circle. And then move your compass to M, and this time, and this is where it's weird because what we practice most in schools is cutting this in half with a perpendicular bisector. Put the compass point on M, move your compass so the pencil goes through A again, and draw the second side. So the first curve is coming from L with your compass, the second part of the curve is coming from M. And now when you join through those, that would be a perpendicular line going through A at right angles. So 2 marks for that. Right, I'm just reading the mark scheme there, and it's telling me that that's an inappropriate method. That's why I've gone quiet. Let's just check. Hold on. Right, well, that works. I don't know why they've got a problem with that. The method that they're looking for is one that you start with the compass point at A, and A then crosses through the line like that, and then you draw from there. It's exactly the same. So that's curious. I'm not sure why they're saying one method over another. Anyway, it's 2 marks. I would still argue there's nothing wrong with the method I showed you. I'll have to do some more digging about that. Interesting. Question 17. Probability trees. Dylan is having a weekend break in Wrexham. The probability that he will visit Erthig Gardens is 0.7. The probability of Dylan going to the Bersham Heritage Centre is independent of him visiting Erthig Gardens. So whether he goes to one or the other or both doesn't have any impact on the other. The probability that he visits Erthig Gardens and goes to Bersham Village Heritage Centre is 0.28. We're going to come back to that in a minute. Complete the following tree diagram. So the first event is here. He's visiting Erthig. He's either going to Erthig or he's not. So between them, those probabilities have to add up to 1. So the first mark is for putting 0.3 there. Then we come to the second event, which is whether or not he goes to the Heritage Centre. Now the most common mistake here is just to pick up that 0.28 there and think that that means that the probability of him going to the Heritage Centre is 0.28. And sometimes the question is set up that way. It's where you have to be very careful. The way that the probability tree works is if you're moving from one event into the other in the same left to right direction, you're anding. So you're saying the probability that he visits Erthig Gardens and goes to Bersham is that times that. When you're using the word and, in probability, that means multiply. So if we go up here, the probability that he visits Erthig Gardens and goes to Bersham Heritage Centre is 0.28. So Erddig is 0.7 times that, which is what we want to put in there and we don't know it, equals 0.28. So if he's visiting Erddig and going to Bersham, he's doing 0.7 times something to get 0.28. So I know that 7 fours are 28. So that means that that is going to be 0.4. Now, just like those have to add up to 1, so do these. He's either going or he's not. And then that pair of branches are repeated down here to cover the fact that he might not go. So that's just a repetition of above. So when you're practicing probability tree diagrams, you need to read carefully what they're asking you to do. Are they giving you an output from a pair of branches, or are they just telling you what goes there? So go back to the website or to wherever you're getting your practice questions from and practice these tree diagrams. They're grade B gold easy marks if you practice them. Calculate the probability that Dylan visits Erddig but does not go to the Bersham Heritage Centre. So he visits Erddig, he's going up there, but he does not go. So he's visiting Erddig and not visiting Bersham. I'm travelling in the same left to right direction, so I need to multiply my probabilities together. 7 6s are 42, 2 numbers after the decimal point, so there needs to be 2 digits after the decimal point in the answer. So marks. Lots of you got the 1 mark for the 0.3 there. Very few of you got the extra work to work out that that's 0.4. So that's a method with an answer of 0.4, and then the final mark is for correctly copying those down, making sure they add up to 1 and bringing them down. And then we got the method mark here for 0.7 times 0.6 and the answer mark for 0.42. Question 18. Okay, so these are dimensions. Again, grade B. We haven't covered them in class yet. And basically what you're doing is trying to determine whether these formulas are going to potentially give you a formula for an area, a length, a volume, or nothing at all. Now, if you know, I would say the easiest way to deal with this is, first of all, let's just check the question. Each measurement of length is represented by a letter. So let's use M for length because it stands for meters. That means that I can replace all of those letters with an M. And the numbers don't have any bearing on the formula. It just doubles it or triples it, makes the length bigger, it makes an area bigger. So I can cross out, not the little 2 because that's a squared, that means something else. But I can get rid of all of these numbers, and pi is a number as well, so that can go. Then I replace all the other letters with M. So if I take the first one, I've got M squared minus MM. M squared minus MM. M times M is, so M squared is an area. Yeah, length times length gives us an area. So that's an area minus M times M, which is M squared, which is another area. So I can take an area from another area. So that one is an area, which I've checked is the one they gave us. So if I look at the next one, M cubed plus M squared M. So the W has become an M, R has become an M, and the D is an M. So M cubed is fine, that's volume. M squared times M is M cubed. So So I've got a volume plus another volume, which gives me a bigger volume. So because those are both the same units, m cubed, that one's going to be a volume. The next one, m plus m plus m. W is an m, meters, meters, meters. Length plus length plus length is just going to give me another longer length. This one, DHR m plus m cubed. Well, m times m times m is m cubed. M cubed is a volume, plus another volume is fine. I get a bigger volume. D plus r squared, m plus m squared. M is a length, m squared is an area. You cannot add a length to an area, they're two different things. So that one is nonsense, or none, is what they're asking you to write for that one. And then the last one, m over m. Well, I can cancel an m, leaving me m times m is m squared, which is an area. So if that's the first time you've seen any work on that sort of question, well, that's going to weird you out pretty big time. But if you want to practice that, certainly on my Jones and Sums website, if you go into a higher tier, definitely there's work on dimensions, but it might also be in the intermediate tier. Marks for that, you get have to have them all right for 3 marks. You get 2 marks if you got 3 or 4 right, or 1 mark if you got 2 right. Question 19, quadratic equations. Which we haven't practiced yet in class, but others may well have. So first of all, they're asking us to factorize this quadratic expression here. And when you're factorizing that in the intermediate tier, you are going to put it into 2 brackets. Now, certainly in class we've practiced going the other way. We've multiplied out 2 brackets, but we haven't done the factorization part. Right, here's the rules. The first thing we do is we list the factor pairs of 21. So the factor pairs of 21 are 1 and 21, and 3 and 7, and that's it. There aren't any more. And then I'm looking for a combination of these pairs that will give me plus 4. So there's no way I can combine 21 and 1 with any combination of signs to get 4. But I can with 3 and 7. If I've got a positive 7 and a negative 3, when I multiply those together, I get 7 3s are 21, signs are different, answers negative, and when I add them, I get plus 7, take away 3, which is plus 4. So when I factorize that, that's what I get. Then to solve it, and again this is something you practice, those 2 brackets are being connected by a multiply. So if any one of those is a 0, my answer is going to be 0. So we say either x minus 3 must equal 0, which when we solve that gives us a value of x equals 3, or x plus 7 equals 0, which gives us x equals negative 7. It's not a difficult set of stages to practice. It's just one we haven't had time to go back over in year 11 in class. But again, if you want to practice those, they are on the website. So there's 2 marks for the factorization. So there's a mark for the 7 and the 3, and then there's a mark for the correct signs, and then there's a third mark for solving it. So we're well into the grade B work here. Now we've got a fractional equation. Now in the intermediate tier, the fraction will only ever be a number on the denominator. The easiest method I can show you, okay, there are better methods, but this one will always work, is if you multiply throughout by all the numbers that are underneath there. So we're going to multiply the whole thing by 5 by 2. Okay, if that was a 3, we'd have to times by 3 as well. So I'm going to do 5 times 2. So I've multiplied that by 5 times 2. I have to multiply this by 5 times 2. And I have to multiply this by 5 times 2. Now I could have written that as 10, but it's easier if I write it like that because you can see what I can cancel. So the 5's cancel, those 2's cancel, those 2's cancel, leaving me 2 bracket 2x minus 3 plus 5 bracket 4x plus 5 equals 5 bracket 11. So the whole purpose was to get rid of those fraction terms. So by timesing by all the numbers that are underneath it, it cancels them out. Now we're into a sort of more straightforward grade C equation. First of all, we need to get rid of the brackets. Multiply whatever's outside by everything in. So I'm going to do 2 times 2x, 4x, minus 2 times 3 is 6, 5 times 4, 20x, 5 times 5, 25, equals 55. Do a bit of tidying here because I've got a 4x and a 20x, and I've got 25 take 6 is 55. Now I'm definitely into sort of grade CD equation. I want to get rid of the 19 by doing the opposite of adding 19, which is subtracting 19. If I take 19 off that, I have to take 19 off that as well. So 24x is 36. Now to get the x on its own, I have to do the opposite of timesing by 24, which is dividing by 24. So I end up with 36 over 24. Now that simplifies, but doesn't ask you to give it in its simplest form. So once you get x equals, the job's done. So the method mark for that is for getting rid of the fraction. So multiplying throughout by 5 by 2 or by 10. Getting rid of all the brackets, it's getting down to that, gets you the next mark. Getting it down to 24x equals 36 gets you the third mark, and the final mark is for getting it x equals that fractional value. So we have practiced that in class, but we didn't spend a great deal of time on it. If you're reasonably confident with equations, then that's quite an easy thing to practice. The final question on the paper is a accuracy in measurements question. This is one that when we work through these, I keep saying if it seems too easy, it probably is. Read the question again. This is the last question on the intermediate tier paper. It's not going to be easy. A cuboid has dimensions of 40 millimeters, 25 millimeters, and 12 millimeters, and here's the trigger. All measurements are correct to the nearest millimeters. They've all been rounded. 4 of these cuboids are stacked together as shown below. Write down the greatest possible value of length A. So that's a clue as well. Okay, this isn't going to be as straightforward as saying, well, it's 40 millimeters, because that's what's given, stupid. They wouldn't be asking you that even in the foundation tier. So because that has been rounded to the nearest millimeter, what they're looking for you to do here is to realize that that's got a maximum value and a minimum value. The maximum value is 40.5. Everything above that would round up not to 40 but to 41. And its minimum value is 39.5. Anything above that would round to 40, anything below it would round to 39.5. So the maximum and minimum values are those two. Even though we know that that actually rounds up, it gives us our boundaries, our limits. So the greatest possible value of length A is 40.5 millimeters. Anything bigger than that rounds up. Now, let's take a look at what's happening in this stacking. Calculate the greatest possible value of the length B. So the length B is having 2 of these side by side. So that's going to take the maximum width. The maximum width is going to be 25.5. So if I've got 2 of those stacked together, then the greatest possible width, 5 and 5 is 10, 5 and 5 is 10, and 1 is 11, is 51 millimeters. And then for part C, they want the least possible value of C. So for that, this is the height that's been rounded. For the minimum, I want that to be as small as possible. So I want the minimum height, which would be 11.5 millimeters, and I got 2 of them. I got that one on top of that one. So the least possible value of length C will be 11.5 plus 11.5, which is 23 millimeters. So if you honestly thought that all they would want you to do on the very final question on the paper is do 25 plus 25 is 50 and 12 plus 12 is 24, then you really aren't being switched on. You don't deserve those marks, which are easy marks to get. So it's straightforward. There's only 3 marks for it, but it's 3 marks that could make all the difference when it's the hardest question on the paper. So there you go. That is the Jones Solutions for November 2019, paper 1.